good morning. In the last lecture of Unit 4, that is wave optics, we discussed about the basic functioning of diameter of Newton's rings. Today we are going to discuss about applications, various applications of Newton's rings experiment. As you know, engineering physics has a wide area of applications in various branches of engineering. So also this interference experiment, Newton's rings, has also various uses. So today we are going to discuss about few applications of Newton's rings experiment. So the first application. First, measurement of wavelength of unknown monochromatic light by Newton's rings experiment. So in this applications, what we are going to derive out? We want to derive out the wavelength of unknown monochromatic light. We want to find out. So to find out, what we have to do? We have to use the Newton's rings experiment. We know the diameter of mth order ring, and the value is dm square is equal to 4m lambda. Equation number 1. Diameter of m plus 1th ring is dm plus 1 square 4m plus 1 lambda r. Equation number 2. Subtracting equation 1 from 2. Equation 2 minus equation 1. So D, in the earlier format, let us take any order. So instead of 1, what we are doing? We are using m plus p. P can be 1, p can be 2, p can take the value 1, 2, 3, anything. So dm plus p square minus dm square is equal to 4p lambda, or wavelength is equal to dm plus p square minus dm square 4p r. So this is your formula for diameter. Equation 3. So what the formula tells? Formula tells that any two diameter, कोई भी दो diameter use करके 1 and 2, 1 and 3, 2, 3, 4, 5, कोई भी diameter use करके, radius of curvature use करके आप किसी भी unknown monochromatic light source की wavelength आप derive कर सकते हैं by using this formula of Newton's ring. So the experiment tells about the Newton's rings applications. Second applications. Let us come to the second applications. Measurement of refractive index mu of an unknown liquid using Newton's rings experiment. So in this concept, what we are deriving out? मेजरमेंट ऑफ रिफ्रैक्टिव इंडेक्स ऑफ अननोन लिक्विड की रिफ्रैक्टिव इंडेक्स हम डिराइव करने जा रहे हैं। तो लिक्विड को कहाँ डालना है? सो लिक्विड इज एक्टिंग एज ए फिल्म इन बिटवीन, इसके रिफ्रैक्टिव इंडेक्स म्यू को, उस लिक्विड को हमने in between plano convex lens and glass plate. So what we are doing, we are using the liquid this is inside a envelope. So this is the liquid of refractive index mu. So be careful, this liquid should be transparent. So how to derive out the value? The value can be derived out by taking measurements in case of air and in case of liquid. So any two diameter, let us take dm square air, its value will be 4m lambda r by mu. This is for liquid. And the same formula, diameter of the same ring for air will be 4m lambda. So after taking both the same ring diameter, both in case of liquid and air, we can take a ratio. We can find out mu by taking dm square air divided by dm square liquid. So this will be your formula for finding out the refractive index of any unknown liquid using Newton's ring. So what you have to do, in case of air film, you have to put that liquid and you have to take the measurement of any diameter, and the same diameter is measured for the film as air, and by taking the ratio you can find out the refractive index of that particular liquid. So in today's class we discussed about the two applications of Newton's rings. The first one is to determine any unknown monochromatic light wavelength, and the second one is to find out the refractive index of any unknown transparent liquid determination using Newton's ring experiment. In next class, we'll discuss some numericals related to Newton's rings or interference.